morning, dear students. Today we are going to learn about the affinities of Ctenophora with some other phylums like platyhelminths and Cnidaria. So before moving to that, we need to understand what these Ctenophora are. This Ctenophora, they are commonly known as comb jellies. Comb, the same thing that we use to comb our hair. So it has some similarity to that comb. In what way is similar to comb? Um, in the body of this comb jelly, they possess array of, here we can see, um, comb-like arranged cilia. So because of that, that comb-like arranged cilia that are helping in its locomotion, they are called comb jellies. So in this picture also, to some extent, we can see that array of cilia here. Anyway, because of that feature, they are called comb jellies. They are marine and so gelatinous, transparent and well. And uh, though they are similar superficially, as we look externally, they are similar to Cnidarians. But even with some aspects, they are different also. Anyhow, we are going to see the affinities of Ctenophora with other phylums like Cnidaria and Platyhelminths in this video. So let's see affinities of Ctenophora with Cnidaria. Going to understand about the affinities of Ctenophora with that of phylum Cnidaria. First point, both have Ctenophora and Cnidaria. Both have strong biradial symmetry. Body symmetry is biradial symmetry. Biradial, I think you know that if we made a cut through a cut that is passing through central axis, we will get two equal halves. So that is biradial. So both Ctenophora and Cnidaria both have biradial symmetry and both possess oral and aboral. Oral means where the mouth located, aboral means the other side, opposite to that oral. So they both possess oral and aboral axis. So that is one similarity. Second point, both have diploblastic body. Diploblastic body means body have two layers like ectoderm, endoderm. So both have only these two layers. So that is another similarity between Ctenophora and Cnidarians. Next, third point. Both have mesoglia. Mesoglia, this is a jelly-like substance seen between ectoderm and endoderm, two body layers. Between these two layers, we can see a jelly-like substance is called mesoglia, and this mesoglia in both ctenophores and Cnidaria, it is mesenchymal, gelatinous mesenchymal. Mesenchymal means it contains that gelatinous mass contains some cellular bodies, cellular structures is possible to see in that gelatinous mesoglia. So that is mentioned here like mesenchymal mesoglia is present in both Ctenophora and Cnidaria. That is another similarity. Then absence of coelom. Both didn't possess a well-defined coelom. Then fifth one, this Ctenophora also possesses an endodermal gastrovascular cavity similar to that of Cnidarians, but it is a little bit advanced when compared with the Cnidarians. Anyhow, both have endodermally originated gastrovascular cavity. Then sixth point, both possess diffuse epidermal nerve plexus. Nerve plexus means network. Diffuse means that nervous system is spread throughout the body in the form of a net. So that is diffused. So in both Ctenophora and Cnidarians, the nervous system is diffused. It is spread throughout its body as a form of a net, that is diffused epidermal nerve plexus. Then presence of statosis. Statosis, we know it's a balancing structure, and this structure also present in both Cnidarians and Ctenophora. Then absence of nephridia. Both did possess a well-defined excretory structure. That is another similarity between these two phyla. Then absence of respiratory organ. All these points we need to memorize. We need to keep in our mind and to memorize. That's the only thing. Nothing is there to explain more in detail. The endodermal gonads. Gonads are endodermally originated one in both ctenophores and cnidaria. And looking to all these features, all these affinities of this ctenophora with cnidaria, some zoologists they treat ctenophora as a class of phylum Coelenterata. Coelenterata is Cnidaria, phylum Cnidaria itself. So, some zoologists treated the Ctenophora as a class of the phylum Coelenterata or otherwise Cnidarians. Next, we are going to see the affinities of Ctenophora with some classes that comes under the phylum Cnidaria. First, we are taking the case of the class Hydrosova. So, let's see. It show Ctenophores show some resemblance with the Hydrosova. First point, the general body surface of Ctenophora. Ctenophora, somewhat it looks like in this way, is the general body surface. It looks like, or it corresponds, it is somewhat equal to the exumbrillar surface of the medusa. Exumbrillar surface. I think you know that what is exumbrillar and subumbrillar surface of the medusa. Medusa is an umbrella shaped structure. It has an exumbrillar and subumbrillar. So, it is this point is telling that the general outer surface is corresponds to the exumbrillar side of the medusa. That is one affinity suggested with that of the hydrosova. Second point, stomadium. Stomadium is this portion. Stomadium, this part is correspond. It is equal, somewhat similar to subumbrillar surface of the medusa. Or I already told you that this is the exumbrillar side and this is the subumbrillar. So, by looking to this area, we may think that how, in what way it is similar. This stomadium is similar to the subumbrillar side of the medusa. So, it's not explains, not pointing that look-wise it is similar to the subumbrillar. Instead, function-wise, this stomatium is similar to subumbrillar side of the medusa. So let's examine yeah, what it mean by this point. Stomadium is somewhat equal to the pharynx portion. So as it is equal to pharynx, uh, it is the beginning portion of the gastrovascular cavity here in Ctenophores. Likewise, in Medusa also, mouth, manubrium, all those structures we can see in the subumbrillar side. And those structures, manubrium, I think you all might have learned in your UG classes, an extended axis-like structure. On its tips present the mouth. So that mouth and manubrium, they also constitute the beginning portion of the gastrovascular cavity. And that structure is also seen in the subumbrillar side. In that sense, we can say that the stomatium function wise, it is similar. It corresponds to the subumbrillar surface of the medusa. And both possess hydrosova and ctenophore both possess simple gastrovascular cavity and a thick gelatinous mesoglea. Mesoglea, I already told you, is a jelly-like substance seen between ectoderm and endoderm. And in Tinophore, two opposite tentacles, a long, in this picture is not that much clear, long opposing tentacle, tentacle, a pair of tentacle is seen in Ctenophora. And these tentacles, these ctenophores, can retract to a sheath. In Cnidarians, in Hydrosaur, so many tentacles we can see around that umbrella-like structure. So that they are giving stress here. Both Medusa, the members that comes under the Hydrosaur, they possess tentacles, and the Ctenophores also possess long tentacles. In that way, they are sharing a common feature. Okay. Next, we are going to see the affinities of Ctenophora with the Anthozoa. This is another class that comes under the phylum Cnidaria. Um, and the first point is in Anthozoa, that is in sea anemones, they possess, sea anemones, chorus, they possess certain ciliated cells in their ectodome. And that ciliated cells, they are considered as the forerunner or precursor structure of comb plate that is seen in ctenophores. Comb plate, I already mentioned you in the beginning of this video, and here I am just drawing and show you what is comb plate. Along the body, such array of comb-like structure. I'm just going to redraw one comb to here. Uh, this one comb, and it possesses a linear array of cilia. And because of the beating of the cilia, this organism, the tenovores are moving. So such arrays of combs are seen along its body. The each such array, each this set is called a comb plate. So here that is mentioning that comb plate is analogous or somewhat similar to the ciliated ectodome that is present in anthozoans. That is the first point. Second, both possess anthozoans and ctenophores both possess a well-developed stomatium. Stomatium, I already told you that it is a structure part of the gastrovascular cavity, and in function wise, position wise, it is somewhat similar to the pharynx. And gonads are endodermal in origin in the case of both anthozoan and ctenophores. Then both anthozoans and ctenophores both release their gametes through mouth. Both are releasing gametes through the mouth. Symmetry is biradial. Biradial means possible to get two equal halves if cut through the central axis. Gut in embryos are four-lobed. So, in the case of anthozoans and ctenophores, during their development time, that embryo possesses a four-lobed gut. So, that also a common feature sharing between anthozoa and ctenophores. And cellular mesoglia. Cellular mesoglia means mesoglia, I already told you, there's a jelly-like substance seen between ectodome and entodome. So, cellular means some cellular structures is possible to see in that mesoglia. So, that's also a common feature between anthozoa and ctenophores. Next, we are going to see the differences of ctenophore from that of cnidaria. First point is presence of comb plates. Comb plates, in the former slide, I have told you that in some cnidarians like anthozoan, they possess some ciliated cells on its ectodome. But those structures, that feature is not exactly the same as that of the comb plate structure that is found in ctenophore. So that we can consider as a unique feature when compared with that of the cnidarians. And in ctenophores, there is no tentacles around the mouth. In cnidaria, it's not like that. Most of the cnidarians possess tentacles around the mouth. And presence of coloblasts. Coloblasts cells are also a unique feature characteristics of ctenophore. There are certain adhesive glandular cells that found in the tentacles for capturing the prey. And aboral sense organ. Oral means the place where mouth found. Aboral means opposite side. So in the aboral side, they possess a sense organ that is not found in nidarian. That is another difference. Mesenchymal muscles. Mesenchyme is a jelly-like substance, and here muscle fibers are seen embedded in the mesenchyme. So that is another difference of ctenophore when compared with Cnidaria. And this ctenophore possesses a definite organized digestive system. In what way we can say that the digestive system of ctenophore is different that of the Cnidaria, in the sense that ctenophore possesses both mouth and anal pore, but Cnidarians they didn't possess anal pore. So that is another difference. Then presence, that's mentioned here, repeating the presence of anal pores in ctenophore is another different from Cnidaria. Then during the development, yeah, it possesses determinate type cleavage. Determinate type cleavage means during the development, earlier time itself, the fate of each cell is determined. So that type of cleavage is found in ctenophore. That is not found in Cnidaria. Absence of a planula. Planula larva is a typical common larvae of the phylum Cnidaria. Is not found. Instead, they possess a sidiped larva. And polymorphism. Polymorphism is a hallmark feature of Cnidaria that is not found in ctenophores. That is another difference. Then alternation of generation and asexual reproduction, that also is a notable feature while we are learning about Nidarians, and that too is absent in ctenophores. Next, we are going to see the affinities of ctenophore with the platyhelminths, phylum platyhelminths. They're flatworms. Two ctenophores like Zeoplana and Ctenoplana. They exhibit following resemblance with that of polyclad turbularians. Uh, Here is one platyhelminth that is polyclad turbularians. Its picture is shown here. These two organisms, these two ctenophores, they show some resemblance with that of this polyclad turbularians. Let's see what are those features that is sharing, that is similar with that of the turbularian. Dorso-ventrally flattened body. They both possess a somewhat dorso-ventrally flattened body, and that characteristics we can see in this one also. Polyclad turbularians. And crawling mode of locomotion. They all have such type of locomotion. In that way, they are similar. Ciliated epidermis, means all these three have a ciliated epidermis. And then lobed gastrovascular cavity. Gastrovascular cavity, lobed, lobed. So that is another feature that is sharing between these three, means ctenophores and platyhelminths. Okay, then we are moving to the conclusion. Conclusion is that ctenophores have some advanced features compare with that of the Cnidarians, that is cylindrite. They are intermediate between radiate and bilateria. Uh, we need to consider it like that. It is an intermediate development in the evolutionary pathway between radiate forms and bilateral forms, and they represent. As we consider we are following the course of evolution. It is an blind offshoot from that Cnidaria area, and it's not a direct means evolved form, evolved group from the need area. Direct evolved group is the platyhelminths, that is flatworms. So it is an offshoot, and because of that it is merely logical to treat them as a separate phylum. So that's it. So with this I'm going to wind up this video. Thank you.
Body, I'm an icon, man. And my girl about a 10. I should fuck her in a Benz.